So the first problem that we're going to solve after we solve the modeling problem is the matrix vector multiplication problem. Okay, and when we solve this problem, we're going to say let m and n be natural numbers. We'll talk about this notation in lesson 1. And then we're going to say let a be an element of R m by n. So the way that we read this is let a be an element of R m by n. That means it's an m row and n column matrix. And we're going to say let this be a given matrix. And then we're going to say let x be, so this is going to be in Rn, be a given vector. Okay. I like to shorten this, so I'm going to call this the MVMP. Could you guess what that stands for? You got it, matrix vector multiplication problem. So if I have a given matrix that's m by n and a given vector that is n by 1, then the MVMP is to find an unknown vector. And anytime I'm going to do unknown, I'm going to switch over to the color red. Brought to you by the color red. In m by 1, such that a times x equals b. Okay? So when we think about this matrix, how many rows does it have? M rows. How many columns does it have? N columns. So I'm going to need blue, I think, sadly. Sugar. So this is the number of rows. The number of rows always comes first in matrix dimensions. If the number of rows comes first, what comes second? Yeah, this is the number of columns. In matrix vector multiplication, we will learn quite soon the inner dimensions must agree. I like to send my Math 2B students around with flags around campus, and you can just march on the president's office and say, the inner dimensions must agree. And she would be like, yes, that's true. They must agree. When you're doing matrix vector multiplication, what's the chant that I want you to set around campus? The inner dimensions must agree. The thing here must agree with the thing here. This is going to be the number of rows of x. This thing right there, what's that? Number of columns. How many columns are there? 1. We call that a column vector. When the inner dimensions agree, they cancel out. We'll learn this. Don't worry about it today. They cancel out, and the size of the output is on the outer dimensions. So what's the size of the output there? M by 1. Okay. The matrix vector multiplication problem, we're going to call this a forward problem. This is a forward problem. AKA, let me see if I can, if we define a function, I'm out here trying to function, f, and this function is going to go from the domain Rn into the codomain Rm. Don't worry about that. What size is my vector n? Excuse me, my vector x. What size is it? N by 1. What size is my vector b? M by 1. So the thing that we take in is the vector x. And then what we do is we multiply that vector x by our matrix A. So the matrix defines a function on n input variables. In this case, we think about the matrix vector multiplication as a forward problem because we literally are doing what we call function evaluation. We're evaluating this function at this input. So you give me an input, so input is given. This, I should be flogged with a wet noodle. because this is a sin. You should never be allowed to use the word given. Do you know what that means? It means, yeah. How many of you have been walking down the street and then you're like, oh, a matrix and a vector, somebody gave it to me. Let me use it and make money analyzing those things. And yet that's what we pretend in math class, right? That somehow you're just going to be walking down the street and then Katya is going to come up and be like, here's a matrix and a vector. Go make yourself some money.
Would be nice.
You know what that means in reality? That means that somebody's probably paid millions and millions of dollars to a group of PhDs who sat in a room for many, 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 many years to produce a matrix. That's called the applied math modeling process. So I hate this word in the standpoint of student learning. I love this word as a mathematician. You know why? Not my problem. You give me a matrix, I'll think about it, right? Yeah, so I just want to be aware of that. Every time you see the word given, I want you to be really, really careful. Given means some group of people that probably need social lives have spent a lot of time and money constructing these things in a way that is quite useful for the world around them. And then once they've done that, they pass it off to an applied mathematician that said, oh yeah, by the way, what you really want to do with this stuff is solve this problem. Okay. So that's the first problem that we're going to work on, called the matrix vector multiplication problem. We call this thing the domain. And it just so happens that in this case, the domain is equal to the domain space. You know what we call this thing right there? Codomain. It's not the range, it's the codomain. This is my favorite. Where did you come from? Where did you go? Where did you come from, Cotton Eye Joe? And I'm going to sing this every time you see me. You know this from 1C and 1D. It's a very, very important problem. Every time you do math, I want you to sing that song to yourself. I want you to do a dumb look on your face. Where did you come from? Where did you go? Where did you come from, Cotton Eye Joe? What's the domain? What's the codomain? What's the range? And we'll talk a lot about that.